When you picture a black hole, you probably imagine a violent cosmic monster, a massive vacuum tearing apart stars and flooding space with blinding radiation. But the closest known black hole to Earth looks nothing like that. Known as Gaia BH1, this object is 10 times the mass of our Sun, and it lies about 1,560 light-years away in the constellation Ophiuchus. In astronomical terms, that places it right down the street. Yet despite sitting in our immediate cosmic neighborhood, it remained completely hidden for billions of years. No telescope captured it. Gaia BH1 is a dormant black hole. It isn't actively feeding on nearby gas or dust. Because it isn't consuming anything, it produces 0 X-rays and 0 visible light, blending perfectly into the dark background of the Milky Way. How do you detect an object that produces no light, no radiation, and leaves absolutely no physical footprint? If an object possessing 10 times the mass of our Sun can sit quietly next door for billions of years, it suggests that our current census of the Milky Way is missing its most significant members. Searching for a perfectly dark object in the Milky Way means looking through a massive, cluttered field of billions of stars and dense dust clouds. In 2013, the European Space Agency launched a spacecraft called Gaia to map that visual noise. The mission was never designed to hunt for black holes. Its objective was surprisingly ordinary, measuring the exact three-dimensional positions and subtle movements of nearly 2 billion stars over several years. As astronomers reviewed Gaia's massive dataset, they noticed one perfectly standard Sun-like star that refused to behave properly. This star wasn't moving smoothly through space. Instead, it displayed a tiny, irregular motion, a slight, repeating wobble. That meant something with massive gravity was pulling on the star, dragging it back and forth. By tracking billions of stars with repetitive precision, the mission accidentally captured the exact gravitational footprint of something completely invisible. Before announcing a hidden black hole, the scientific community demanded verification. Teams turned to heavy ground-based telescopes to cross-reference Gaia's math and test every alternative. First, they checked if the hidden mass was a faint companion star. But a star large enough to cause the specific pole would emit some detectable light, and the space next to the wobbling star was completely dark. Next, they ran the equations to see if the invisible mass could be a massive planet. The sheer weight required to create a wobble this severe ruled out a planet entirely. Finally, the ground observations confirmed the movement wasn't a measurement glitch or a sensor error. The star was truly being pulled by a physical object in space. This animated scale illustrates the final calculation. The unseen object possesses nearly 10 times the mass of the Sun, yet it emits absolutely 0 light. With every alternative eliminated, only one physical possibility remained. They had found the closest known dormant black hole. The universe had kept this object perfectly hidden in the dark, but its own gravity ultimately gave it away. Knowing that a massive black hole has been sitting quietly in our cosmic neighborhood usually prompts an immediate reaction. Are we in danger? Black holes do not roam through space hunting for planets to swallow. Their gravity follows the exact same laws of physics as any other object with identical mass. This thought experiment proves the point. If our Sun were instantly replaced by a black hole of the exact same mass, Earth would continue along its circular orbital path, completely undisturbed. The lack of heat and light would be an issue, but the gravitational pull wouldn't change. Located 1,560 light-years away, Gaia BH1 exerts 0 gravitational effect on our solar system. We are completely safe. The real consequence of this discovery is what it exposes about our blind spots. For decades, our search methods relied entirely on finding loud, violently feeding black holes that release massive amounts of energy. Because astronomers were only looking for the active ones, current estimates now indicate our galaxy could contain tens to hundreds of millions of these quiet, dormant black holes. This realization is shifting how space missions are planned. Astronomers are now designing new telescopes specifically to hunt for the subtle gravitational fingerprints these objects leave behind, rather than waiting to see a flash of X-rays. Gaia BH1 is a starting point. It proves that the Milky Way is secretly teeming with invisible giants, and we finally have the tools to find them.